Okay, this is lesson 2 of module 2, and in this lesson we're going to talk about a specific type of transformation called a translation, and we're going to look at the properties of translations. Okay, so if I showed you this diagram again, and we looked at this in the first lesson, and asked you what is the simplest way to move the figure on the left over to coincide with the figure on the right, what would your description be? Okay, so if you said a slide, then you're correct. We can just simply slide it up and over. Okay, but we want to be more mathematical than that, more precise, and so we're going to have to know a few things. So what would we need to know to be able to get that slide to go right to the right location? Now, when we used our transparency, we could just stop in the correct place, but without a transparency, how could we describe, what would we need to know about where we're going with this figure on the left? Jot down some notes about what you think. Okay, so what we really want to know is we want to know the direction. What direction are we heading, and how far do we need to go? If we can tell the direction and the distance, that's going to describe this move completely. Okay, and the way we're going to do that is kind of interesting. We're going to do it with this arrow type thing. This is called a vector. And a vector has a beginning point and it has an ending point. So it has a length and it also has a direction. So you can see this one slants up and to the right. So we want to take this figure, we want it to kind of go up and to the right, and we want it to go that distance of this AB vector. That's the distance we need to go. So that vector describes our translation. So what we're really going to call these moves, this rigid motion, is a translation along a vector. So whenever we say we're going to translate something, we want to specify the vector that we're translating along. Okay, so let's talk about what a vector is. A vector has length and direction, like we said. It's a directed line segment, so it has this beginning point, an ending point, and a length and a direction. Okay, so let's see. So if I have this vector AB, I've kind of drawn it similar to the one up top. The way I want to refer to that vector is going to be with this notation. I'm going to write AB, the starting point A, the ending point B, with an arrow over it. Okay, but if I had a similar vector where B was the starting point and A is the ending point, and you can tell that by which direction the arrow is going, I'm going to name my vector this way. I'm going to put the B first because it's the starting point, A is the ending point, and then put the arrow over it to show the vector notation. So through the course of this lesson, we're going to be experimenting with vectors using our overhead sheets, and so we can understand how to use the overhead sheet to show the translation along a vector. And we're going to find that there could be multiple vectors that would work for a given translation. So I'm going to draw another one here. Vector DE is a vector that would describe the slide from the figure on the left to the figure on the right. So notice what I've done. I have chosen corresponding points. So this point A corresponds to this point. It's in the same location on my image. So remember, this is my original, and this is what we refer to as the image. So B would be the image of A, and E would be the image of D under this translation along this vector. So this point here corresponds to that point there. And any point on this figure is going to travel in the same length in the same direction. So this vector could actually exist anywhere on the plane and accomplish this transformation. But in order to fully understand how these vectors work for translations, we're going to need to actually do it. So now's the time to get out your overhead sheet and a blank sheet of paper, and we're going to be doing this together. Okay, in order to demonstrate what to do with your overhead, I'm going to do this video is going to look a little different than others. So with some kind of straight edge, a ruler will work fine. We're going to start by drawing a translation vector. So you know what one is. So it has a beginning point and an ending point. And we'll call this one A, B. Okay, so there's our translation vector. And I want to show you what happens when we translate a point. So let's do our point P over here. I'll label it point P. So what we want to do is find the image of P under our translation. And so I'm going to use tracing paper because I'm not going to get as much glare, I think. So I'm going to try this. But you have your overhead sheet. So we have got, so what I want to do is I want to trace everything onto my overhead sheet or tracing paper. So my vector ends up right here. Okay, so there's A and B. And I also want to get point P here on, on that. And what I want to do now is I'm going to move along this vector, and I want point A to become where point B is. And so kind of a useful thing to do for this is to draw, I'm going to do it using pencil, but extend your vector. Draw the line that contains the vector. Okay, so using your straight edge, do that. And that'll help me keep my direction going in the right, keep me going in the right direction. Okay, so let's line everything up again. So there we go. So I'm just going to take my this entire sheet and slide it. So I'm sliding, which is what a translation is, right? I'm sliding it up in the direction of the vector, the length of the vector. Because remember, that's what the vector tells us, is how far and in what direction. And so now I've got this, I can see where my P was. And now this is my translated point, my image. And so I'm going to mark it. So to do that, I've got to kind of lift up my overhead sheet, draw it, draw my point, and then I'm going to label it. I kind of was off a tiny bit here. I think this is easier to do with your overhead sheet because you can actually see through it. But there it is. So there is my image, and I'm going to call it, since my translation I'm calling T, this is translated point P. So that's our image, and that's the original. I'm going to put a link on this video and also send it in email to an online video of this too, so you can see it again. But let's just do it one more time, just so we know how we found that translation. So we traced our vector and we traced our point, and then we slid in the direction of the vector, the length of the vector, so that the beginning point matched up with the ending point, and then we were able to mark our translated point. So that's a translation. Okay, for this example, you're just going to need another blank sheet of paper and just draw along with me. So on your blank sheet of paper, draw a vertical line, and we'll call that line L. And then we're going to draw a couple points nearby. We'll have a point Q, and then up around here, it's not really important where that is the point P. Okay, so line L, point Q, and point P. And then somewhere down here, we're going to draw our vector. So I'm going to make my vector a different color. So my vector is, I'm just going to draw it right here. It has a starting point and has an ending point. And I'm going to call my this translation translation T. And I'm going to use my overhead to do this. So I'm putting my overhead sheet on top of the thing. I'm getting some weird lighting, but I think it will be okay. Okay, so I'm going to trace my translation vector here. Oops, I didn't do that with an overhead marker. I'm going to trace my translation vector here in blue. Okay, and once again, I forgot to do this again, but let's go ahead and make sure we know what line this vector lies on. So if you have a ruler, just extend it, kind of a dotted line in the direction that the vector's pointing. And that just helps me to slide it accurately. All right, so now the only thing left for me to do is to trace my line. So I'm going to just get a red one just so you can see the difference. Okay, so here's my line that I want to translate by my translation T. I don't need to label that. And there's point Q and there's point P. So my line and my 2 points there. Okay? All right, so now, just like we did the last time, we're going to take the start point of my vector is going to become the end point. So slide it along, right like that. And so now you can see that this, and I could draw it on my paper, this is the image, but it's not F because I've called this one T. Okay, this is the translated point P. This is T of Q. So these are the images. And look, the line has its own image. So this would be the image of the whole line right there. But we really only use that for points on the line. So let's go back. Let's go back. And I'm going to get it back right where our starting point was. I'm just going to define a point on this line as well that I'm going to translate. So we'll make this point U. So we'll have an image for point U as well. So slide it up the vector so the end point becomes the starting point. And I didn't have that one labeled. I labeled it in the wrong place. All right. It is right there. That's point U. Okay, so slide it up once again. Here we go, third time's a charm. All right, so this is the image of U. So this is T of U. So we have T of U, T of Q, and T of P. If we looked at the translated, so this is just my translation, you wouldn't be able to tell the difference between the two. They're exactly the same. And that's the point, is that every point will move the same distance in the same direction. Therefore, they'll be in the same relationship to one another when they're translated. Okay, we're going to use this the same drawing that we have here. So you have, if you haven't yet, on your paper, I don't have an overhead on this now, I've drawn the images. Okay, and I want to show you some different notation. Instead of having to write T of Q and T of P, we can just write Q, and then this is Q with a little line up there. We call it Q prime. This is P. This is P prime. And that's just another way of noting that it's the image under that translation. This is line L. This is line L prime. And we had point U, and I didn't label the translation of U, but let's do that. It's right here. So this would be U prime right here, and that's a point. Okay, L is the whole line, L prime is the whole line, U prime and U are just the points. Okay, so what if I had, using this same translation, on my paper, if I had drawn some little image like so. I can come back here with my original. I'm going to get everything lined up. I'll use blue this time, but you get the point. The colors aren't that important. So now I'm going to translate that image. Let's call it that shape. What do we want to call this shape? We can call this shape, we'll call this shape G. Okay, and so its image is going to be G prime. And again, we're going to translate on the same vector. So its image ends up right here. And I can kind of almost trace it by its shadow right there. Okay, pretty close. That becomes G prime. Okay, so what we're doing is we're discovering some properties of translations. We know that points map to points, lines map to lines, figures map to figures that are the same shape and size. And there's one last thing we want to look at. And so what I'm going to do right now is I'm going to draw an angle from the end of my line to Q and P. Okay, I don't know what that angle is. There's some angle right here. We can call it angle B. All right. And again, I'm going to get my overhead back here. Right there. And I'm going to translate this angle here. So I've got to draw that onto my sheet and translate it up. Okay, this seems pretty obvious, but we're being very mathematically precise. And if I want to draw that angle in here, I'll get my paper up so I can do that. This is kind of tricky. Well, not really, because it's right there. I can see that that angle maps to another angle, so B and B prime. So an angle maps to an angle of the same size, if I had drawn it correctly. Okay. All right, we're going to work on exercise 1 in your notes now. And you'll see this diagram. And the directions say that you're to draw at least 3 different vectors and show what a translation of the plane along each vector will look like. Describe what happens to the following figures under each translation, using appropriate vocabulary and notation as needed. Okay, so you get to decide where these vectors are. So why don't you work on that, pause the video, and then come back and I'll show you my work, which will be a little bit different from yours, but similar. So I've got my overhead sheet. I'm going to trace my vector so I know where it goes. And I'm going to trace one of the figures here. So we'll do V. The trickiest part of this is drawing underneath your overhead sheet when you get there. So I'm going to translate this shape along this vector. Okay. So now I can lift up and draw V prime. So it's right here. Okay, so this would be V prime along that vector. Okay, and I could do the same thing with another shape. Let's do Q. Okay, we're going to again translate along AB. And you should notice something about the location of these shapes. Their location should be pretty similar in relationship to one another. Okay, I did pretty well there. Okay, so there is Q prime. Okay, so I can draw a different vector. What if I drew, let's see, let's draw a line right through here. And I'll draw my vector. This time I'm going to draw a shorter vector, maybe just like that. We'll call this vector CD. Okay. I'm going to line these things up. So what if I translate V and Q by DC? Oh, I have to draw my vector first. They're already traced, but let's trace my vector so I know how far to go. Okay, and I'm going to translate right there. Okay, so they basically just ended up right on top of each other. So we'll draw these in blue. And then here's my V. Okay, so I want you to practice with this. You were asked to do 3 vectors. Okay, so there's V prime again, but under this translation, Q prime under the blue translation. We'll call it translation B and G for green. Okay, so your paper should look something like this. By the time you get the third one done, the third one could be, maybe the third one should point in a different direction, like maybe this way, you know. You could have a vector going that direction. Okay, so the idea being that when we do this type, this is only one kind of transformation. We'll also be doing rotations and reflections. The shapes don't change. They don't change size. They don't change at all. They're exactly the same size and shape. Lines go to lines, points to points, and figures to figures of the same shape. Okay, now you can work on exercise 2 independently. For some of you, you might want to have your transparency out for this exercise. For others, you may be able to just figure it out on your own without using the transparency. But for most of you, you might want to get it out just to verify what you're thinking. So let me just read it with you, and then you can pause the video and work on it and come back. So you're asked, this diagram contains segments, lines, angles, And of course, they all contain points. And you're going to, it has the figures and their images under a translation along HI. So we need to find HI, and it's this vector right here, HI. So you're asked to fill in missing labels for points and measures. And notice we're using the prime notation. So we've got, some of these are already labeled without the prime notation, so you know that's an original point. And some of them have prime notation, so you know those are images. Okay, so go ahead and pause the video and work on exercise 2. All right, so I'm going to talk us through this exercise without using my overhead sheet, but you certainly, you know, like I said, could have yours out. So our vector is right here, it's HI. And if you notice, our vector is, you know, a given length, and it points kind of down and to the left. So maybe the most obvious one to start with would be the angle ABC, whose measure is 31 degrees. And what I'm looking for is an image that would be down and to the left slightly. So notice that all of these points are down and a little bit to the left, down and a little bit to the left. So I know that this, this one right here, I'm going to get a darker color here, must be A prime. And this one here is C prime. And then the vertex here is B prime. Okay, and I need to also note the measure, and I know that this is a rigid motion under that translation, and so the measure of that angle won't change. And that's real easy to see from the transparency. We just slide it down. It's exactly the same figure in a different location on the plane. Okay, so we've also got a line segment here in the middle. It's 5 centimeters, or it's labeled 5 centimeters. This is not to scale, most likely. And we have 1 point labeled. So our starting point is here, so we're going down and to the left. So down and to the left, and here would be the image of E, point E. So this would be E prime. All right, and this over here we have labeled D prime already, so its original point would be this one up here, so I'm just label this with a D. Okay, so kind of that one went backwards, so D is the image under that translation is D prime, E and E prime. And once again, the segment, because I'm just translating it to a different part of the plane, is going to have the exact same measure. So it's going to be 5 centimeters. Okay, so now we have these two lines that clearly are images of one another under the same translation. So let's look at these points C and I can't even read it here. Okay, sorry, these are points F prime right here and G prime. Okay, so these are the images under this translation that we've got going on here. So the original point for F prime would be labeled F, and the original point for G prime would be labeled G. So those are, get that better. So here's our original figure, and here's our image labeled with our prime notation. So this is a line, and it's still a line with the distance between these 2 points not changing. The distance between F and G is equal to the distance between F prime and G prime. Okay, so what we want to be able to say with translations is that they are rigid motions, and so you've verified this experimentally, and so could we say that a translation maps lines to lines, angles to angles, segments to segments? Would you agree with that under this translation? And also, would you agree that it preserves lengths of segments? So the length of segment DE would be the same as the length of segment D prime E prime. The length of segment FG would be the same as F prime G prime. So it preserves, do you believe it preserves the lengths of segments? And then thirdly, we're mapping angles to angles, but do we believe that it preserves the angle measure, the degree of the angles? And when you did this experimentally, you saw that yes, it does. It preserves the degree measure of the angles. Okay, so let's just walk through it again. So some of the properties of translations along a vector would be that it maps lines to lines, segments to segments, points to points, and angles to angles. And then in addition to that, the lengths of the segments are preserved. They're the same. The image is the same as the original. And the angle measures are preserved, with the image being the same angle measure of the original. Okay, we're going to talk about one last thing about translations that's going to help us when we do the next lesson, which is translating lines. So we want to look at a single point, and we're going to call it C, and describe its image under a translation. So let's get our translation vector and our point C. So our translation vector is AB, right here, and our our point is over here in the plane, point C. So you could draw this on a paper and use your overhead, but we've done enough of this now that hopefully you know by experience what this is going to look like. So if I want to find out where C prime is, I'm going to trace it out, and it's going to be in the same direction and the same length as vector AB. And so I can label my point C prime, the image of C, under translation along vector AB. If I wanted to compare, so I want to describe this image under this translation. So one thing you might notice is that the distance from C to C prime has to be the distance from A to B. So it's the length of the vector. And so the way we can write that is that the length of AB is equal to the length of C prime, because I've moved it the length of my translation vector. So that seems to make common sense. Another thing is that the line that contains AB, so if I were to draw a line through there, and let me just go ahead and draw that line. I'll draw it in gray. Here we go. If I draw this line through vector AB, and I draw the line through what is really vector C prime, those two lines are parallel. And you've been noticing this as we do these translations, I think. And so that is one property of translations, is that the translation vector and vectors of translated points between the original and their image are parallel lines. That's going to come in really handy when we start looking at what happens when we translate lines in the next lesson. Okay, so I think we have pretty much gone over everything that's in your lesson summary here. So I encourage you to just look over it one more time. Make sure you understand all of the vocabulary and understand what's going on, and then you can move on to your exit ticket and problem set.